You know the promise of cloud gaming, right? Play these huge, graphically intense games on basically any device you own. But the reality, well, for a lot of us, it's just this frustrating mess of lag, stutter, and freezes, even when you have a super fast internet connection. So what is actually going on here?
This is the question that drives every gamer absolutely crazy. You pay for good internet, you run a speed test, everything looks great, but the second you get into a crucial firefight, the whole thing stutters and bam, you're looking at a game over screen. Why does that happen?
All right, let's get right into it. The heart of the problem is, believe it or not, pretty simple. Your network is basically flying blind. It sees a whole bunch of data coming from a gaming service, but it has zero idea what's happening inside that game. So to your network, an insane split-second boss fight looks pretty much the same as you just sitting in a menu. And this analogy just hits the nail on the head. Bandwidth is only one piece of a much bigger puzzle. It's like it tells you how loud the movie is, but it tells you nothing about whether the acting is any good. To really get what's happening with gaming quality, your network needs something it doesn't have: context. It needs to know what game you're playing and, most importantly, what you're doing inside that game at any given moment.
Okay, so let's dig into that idea of context. A team of researchers from the University of New South Wales, Canopus Networks, and Pennet knew that not all gameplay is the same, and they broke it down in a really fascinating way. So first up, they figured out there are basically two major types of gameplay patterns. On one hand, you've got spectate and play games, think Fortnite or Call of Duty. You have these intense bursts of action, sure, but you also have a lot of downtime where you're spectating your teammates or just waiting in a lobby. Then you have continuous play games like Cyberpunk 2077. These are more about long, uninterrupted sessions of just exploring the world. Your network really ought to be treating these two types of games very differently.
And even inside one of those games, what you're doing is constantly changing. The researchers broke it down into 3 key stages. You've got active, that's when you're in the thick of it, right? Driving, fighting, making split-second decisions. This needs the absolute best network performance. Then there's passive, that's when you're just watching, maybe a cutscene or a teammate's camera. Still needs to look good, but it's not as critical. And finally, idle. You're in a menu, a lobby, the network demand here is super low.
But here's where it gets really interesting. Look at how that time actually breaks down in a typical shooter. You spend 23% of your time being passive, and another 21% being idle. If you add that up, that's 44%, almost half of your entire gaming session where you aren't even actively playing. And this is the whole point. Your network has been treating that entire session like it's 100% active, which is just crazy inefficient and leads to all the wrong conclusions about how well things are working.
Okay, so if that's the problem, how in the world do you fix it? How do you give the network the eyes it needs to finally see all this context? Well, this is where the real breakthrough happens.
The team came up with this really clever two-step solution. First, the system analyzes the traffic to fingerprint the game, which means it can identify the exact title you're playing. Then, second, it's constantly watching your data flow to figure out which stage you're in at any moment: active, passive, or idle.
And you're not going to believe this. That first step, identifying the game, it takes just 5 seconds. Within 5 seconds of you launching a game, the network knows if you're about to drop into Fortnite or explore the world of Baldur's Gate 3. That kind of speed is an absolute game changer.
So, how does it do it that fast? Well, when a game launches, the video stream of that animation has its own unique signature. A machine learning model looks at the size and timing of the data packets, and it sorts them into patterns it calls full, steady, or sparse. Each game has its own unique combination, so by matching that pattern, it knows exactly what game it is. It's kind of like digital forensics for your game stream.
And what about step 2, tracking what you're doing? That's all about the conversation happening between you and the cloud server. See, when you're actively playing, you're sending a lot of data upstream from your controller. But when you're just passively watching a cutscene, that upstream traffic drops way down. By watching that change, the system always knows what you're up to.
Okay, so the theory behind this is fantastic. But does it actually work in the real world? Let's take a look at how this new approach completely flips the script on how we measure gaming performance. First, let's get our terms straight. We've got the before and the after. The old way, which the researchers call objective quality of experience or QoE, just looks at raw numbers like frame rate. The new way, which they call effective QoE, combines those numbers with the game context we've been talking about. It asks a much smarter question. Was the frame rate low because the network was actually bad, or just because the player was sitting still in a menu?
And just look at how wrong the old way got it. I mean, it's kind of nuts. For a card game like Hearthstone, which has a ton of static screens, 100% of the sessions were getting flagged as having a medium or bad experience. Even in a game like Cyberpunk 2077, more than half the sessions were getting flagged as bad just because of time spent in menus or talking to characters. The network thought things were broken when they were working perfectly.
Now this slide is the big payoff. Let's stick with Cyberpunk. Remember how the old method said a whopping 56% of sessions were medium or bad? Well, look what happens when you add that context. The whole thing flips on its head. A full 95% of sessions are now correctly identified as good. The false alarms, they practically disappear. It turns out most of the time, the network was never the problem in the first place.
And this isn't just some theory from a lab. The team actually deployed this system live on a real internet service provider's network, one that hosts NVIDIA's GeForce Now servers. Over 3 months, they analyzed hundreds of thousands of hours of gameplay. And the result? They were able to cut through all the noise, get rid of the false alarms, and finally, focus on finding and fixing the real network issues that were actually affecting players.
So yeah, this is obviously amazing for gamers, but the story doesn't end there. The implications of this kind of technology are actually way bigger than just fixing lag.
What we're really talking about here is a huge shift. We're moving away from an internet that's just a dumb pipe shoving data around and toward a smart, context-aware network that actually understands what that data is for. It's a fundamental change in how our networks can operate and optimize things for us.
Like the researchers themselves said, this whole thing enables precision. Instead of just guessing, network operators can pinpoint the actual problems. And that means better service for everybody, whether you're gaming, jumping on a video call, or streaming a movie. It's all about being more efficient and more accurate.
And that kind of leaves us with this really cool, kind of mind-bending question. We just saw how teaching a network to understand the difference between a boss fight and a menu can completely revolutionize performance. So, what's next? What other things could be totally transformed if the network understood not just the data, but the meaning and the intent behind it? The possibilities are pretty staggering to think about.